Okay, so remember the basic form of an exponential function is this.
Mm-hmm.
And you could plug in like 0 and 15 for x, y, and solve for a, but you know what's going to happen. B to the 0 is going to be 1,
Mm-hmm.
leaving you with just a being equal to 15.
Yeah.
So equation will be y equals 15 times b to the x.
Yeah.
Then you can plug this in for x and y. And then if we divide by 15 or multiply both sides,
Mm-hmm.
those cancel, those cancel. So b would be 1/4.
Mm-hmm.
So the equation would be y equals 15, 1/4 raised to the x power. That's 15. Sorry, that's number 15. That's how you handle that one. So all these problems are going to be very, very similar. I mean, if you think about it, you already know your a value is 0.5. I'll kind of tee these up and have you kind of tell me what to expect. Y equals, so yeah. Okay, so starting with 16, after I figure out this is a, I put it over here. So 40.5 equals zero point 0.5 times b to the 4. What do I do to solve for b?
Um, Wait.
So you want to get b by itself. So right
Yeah.
now, you got to move stuff around.
Mm-hmm.
So what's your first step to solve for b?
Just move zero. Move A. Oh no no
So, so yeah, divide both sides by what?
by zero. Wait, no, by 64.
No, I'm doing number 16.
Uh
So you have zero point 0.5 times b to the 4 equals 40.5. So you
mm-hmm.
want to get rid of the zero point 0.5, right?
Yeah.
Right now it's being multiplied. What's the opposite of multiplication?
Vision.
So we divide by zero point 0.5, not
Yeah.
zero. There's no, I don't see a zero. I don't know where to get a
Yeah.
zero from. Okay.
Uh,
And then let's use a calculator. What's that going to be? 40.5 divided by zero point 0.5.
40.5 divided by zero point 0.5. There we
Yeah, you can use a calculator.
go. 81. No,
Okay.
it's 81, is it?
Yep. And then last step, you need to get b by itself. It's not quite by itself because raised to the 4 power.
Mm-hmm.
So what do you have to do? What do you have to do to both sides to get rid of the 4 power?
Um, Wait, can you sorry you cut out? What did you say?
What do you have to do to raise it? What do you have to do to well, let me make sure I'm on the right Wi-Fi. Yeah. What do you have to do to get rid of the 4 power? What do you have
Um,
to raise both sides
oh,
to?
you have to divide it by four.
Well, you don't divide. You raise it.
Wait.
You, you want to get rid of the power, right?
Mm-hmm.
So if it's b to the 4, obviously you want to right 4 divided by 4. But what are you actually raising it to?
Oh, hold on.
I'm sorry. What was that?
You think? Hold on. So I'll raise it to
Well, just think about it. You want it to be 1, right?
Yeah.
So what do you multiply to? Because when you raise a see, when you raise a power to a power,
Mm-hmm.
I think I know why you're stuck because you forgot the property. That's okay.
Yeah.
When you raise a power to a power, what happens? If you have b squared raised to the third, what does that become? B to what power?
B to the third power.
No, b squared raised to the third power.
Oh. B to wait, would that be B to the second power then? Or
Wait, b to the what? Sorry.
B to the fourth?
No, no. B squared raised to the third power. What does that become? You know this. You've done this many times.
Wait, I'm like blanking for some reason.
Okay, okay. If you have b squared raised to the third power, how many times do you repeat b squared?
Three times.
Exactly. How many b's you got?
Three.
No, you don't. Count it, dude.
Oh,
B squared, B squared, B squared. How many B's is that?
three. Oh, wait.
I don't know where are you getting three from.
Oh, it's six. Oh my.
Yeah, two plus two plus two. This is like first grade math,
Oh,
dude. Come on.
idiot.
B6. So you're multiplying, right?
Mm-hmm.
So what do you multiply? So basically that's what you have to do. When you raise a power to a power, you're multiplying. That's okay,
Mm-hmm.
you forgot that. I'm reminding fresh your memory. But something like that, you gotta just add it. Like don't you know that. So anyway, if you have B4, what do you raise that to? If you want to make that one, raise it to the
Second power twice.
well, if I raise it to the second power, it becomes B8, right?
Oh, it's
That's
fourth.
worse. So sorry, say it again. Yeah, I think you said it.
The fourth.
Fourth, good.
Yeah.
Good, good. That's what you want to do. So now you can use the calculator. If you raise 81 to the 1/4 power, what does that become?
So 81 times what?
No, 81 raised to the 1/4 power.
How would I do that?
Do you have a calculator?
Yeah.
Yeah, you could do it in Desmos. Just pull up Desmos and just do that. You could easily do exponents. I'd recommend Desmos if you don't have a. Actually, a lot of people are using Desmos these days, not graphic calculators.
Would it be three?
Good, awesome. Okay, we're gonna go a little faster because that took you a while. But y equals zero point 0.5.
Mm-hmm.
Yeah, and I have to have you do it because I know I can do it, but I have to empower you to do so you are successful tomorrow.
Yeah, for sure.
So okay, so there we go. All right. So now we're gonna do this again. Now this one's easy because b to the one's already b.
Mm-hmm.
So you just divide by 15, and you can reduce it if you want to zero point 0.8
Mm-hmm.
or 4/5. So 17z is y equals 15 times
Mm-hmm.
4/5 or zero point 0.8 raised to the x power.
Yeah.
Okay, here. So again, your goal is to get b by itself. So there's two things happening. It's being multiplied by -1 and it's being risen to the sixth power.
Mm-hmm.
So what should be my first step in getting b by itself for number 18?
If you plus one.
Y plus, I thought -1's being multiplied, not added.
Oh, so you divide, my bad.
Right. Yeah, always do the opposite. So 64 equals b to the 6.
Mm-hmm.
Okay, just like we did for number 16, what do I raise both sides to?
Six.
1/6.
Yeah, 1/6.
Okay, now use your calculator. Tell me what you get when you do that.
The 64 to the 1/6 power.
Correct.
I get two.
Good. You get so y equals -1
Mm-hmm.
times 2 to the x power.
Yeah.
Okay. All right. So let's see what else we got here. Okay. So you have a word problem and they give you the formula. So your interest rate's 4. So you do 0.04. Always right.
Oh, I'm pretty good at these, I would maybe think.
Okay. Well, let me have you do the calculation. I'll just write everything out.
I learned this just
Mhm.
to only look at the first sentence. That's correct or not.
Yeah. NT represents N's the number of times you compound per year, and T is the number of years. So if you're doing 12 times a year, because monthly, and you're doing it for 6 years, that's 72, of course.
Yeah.
And that's a A. And the principal course is 1500.
So when you do 1500 times 72 divided by 4?
1500 times all that junk. So you have to just punch in the Desmos. It's just easier that way. So just
Mhm.
1500 times all that junk. Tell me what you get when you do that. I'll do it as well on my handheld calculator. We'll see if you get the same thing.
I can't use that mess on my test. So
You can or
using,
can't.
I can't. I'm charging my
Um,
calculator right now.
do
So
you have a calculator with you?
yeah,
Okay, that's fine too.
15.
Tell me. I want to make sure you can do it. You can compute it correctly.
Mm, hold on. Um, how do I do a file? I got a new calculator. I don't really know how to work it.
TI-84.
Yeah, the TI-84.
All right, here I'll help you out.
How do I do a fraction on it?
I'll show you. No, you don't need to do fraction. It's okay. This slide's a little clunky, so I don't like it, but it does at least. So you do 1500,
Hmm.
1500 time parentheses. So you see how I have that so far?
Yeah,
Okay. You do 1 plus, you do 0.04 divided by 12,
let me see this real quick.
like that. Then raised
Hold on. Yeah, let me see that.
to 12 times 6. So it should look like this.
Hold on, let me try getting there.
So see if you can type that in.
Wait, where do you get the slash?
Divide, the divide symbol.
Oh yeah,
Yeah.
yeah. Wait, so how would I get it to the sixth power?
12 times 6. You hit the exponent button, which is right below clear,
Mm-hmm.
right there. So you want to raise that to the 12 times 6 power.
Mm-hmm. One second. Mhm.
Let me know when you have it all worked out.
I got uh I got 1.4929.
No, not. You have typed in like this.
Oh, I didn't raise the 12.
So that's what you want. You want just copy that. That's it.
All right, that's cool.
Tell me when you got it.
All right. Mhm.
Shouldn't take that long. Should only take 5 seconds.
Yeah, 1 second. Um, is it 16:35, 8,
No,
3?
no.
Okay. Uh, hold on 1 second.
Just type in like I have it.
Mhm.
I can walk you through step by step if I need to.
All right. Uh,
Okay, so do you have 1500?
1500, yes.
You have times.
Yeah.
Then parentheses.
Yeah.
1 plus 0.04/12.
Wait. Mm-hmm.
Okay.
Then
And the parentheses. And then hit this button to raise it to an exponent. So it's a superscript. The button that's right below clear looks like a little carrot top.
is it 1906?
Good. There we go.
Ah,
What were we doing wrong? Just out of curiosity.
I don't. I wasn't like. It would reset after the 12 and it would like screw it up. I'm pretty sure.
Well, just keep typing it. I mean, if you had this,
Yeah.
obviously that's something else.
Yeah.
So that wouldn't make sense. If you multiply six, and it could be a much larger number. Okay, let's keep going. All right, so the population of San Mateo has been declining. Okay, 2024, it's that declining rate 1.42%. What will be the population? Okay. So initially, we'll say this is initial.
Mm-hmm.
So T represents the number of years
Mm-hmm.
since 2024. Okay, so A, and then the rate's 1.42% to 0.0142.
Mm-hmm.
Um, and you don't know what T is, so you have to solve for it.
Yeah.
And you want to reach 80,000. And what's one minus? It's 0.9858. All right, so now um, you want to solve for T. Now, how would you guys do this in class? So there's a few ways you could do it. I'm just kind of curious. I want to do whatever your teacher does.
Mm-hmm.
How did
He
you
does
teach
like
it?
all the ways. Like he just says whatever you particularly like.
But which way?
I have no clue. I mean, um,
Have you guys done logarithms?
I haven't heard of that one before.
Well, like log something like this. I don't think you guys have. Have you guys done something like log base 2 of 8?
No.
No, okay. I don't think so because I don't remember you doing that with you. So what you could do is you could divide by this number
Mm-hmm.
because your goal is get t by itself. So just to kind of make the left side, make the right side more simple.
Mm-hmm.
I'll call this x. Let's change the t to an x and divide
Yeah.
by this, whatever that is, which is 0.815.
Mm-hmm.
Now, how would you solve this? You could graph each side separately.
Mm-hmm.
And if you graph it, you just want to see where they touch. Now, here's the thing. So what you do is you simplify the equation, just as I show you. So you probably should watch this portion of the video because this is kind of important.
Yeah.
So you simplify the equation, and then the thing is that if you think about x represents time. Time can't be negative, and it could take more than 10 years. Maybe it might take 100 years. So I'm going to increase that.
Mm-hmm.
And also for the y is not going to be negative either.
Yeah.
You could probably go from like 0 to 10. That's fine.
Yeah.
So I see they touch right there. To find where they touch, if it's second trace, pick option 5 and just hit enter 3 times. One, two, three.
Mm-hmm.
You tell where the intercept was about 14.3 years. So that'd be the year 2038.
Yeah.
Now, I didn't see the other part of the question, which was,
Mm-hmm.
and that's just you plug in 10 for x or for t.
Mm-hmm.
And you can work that out. So if I do that in the calc, that's pretty easy. 98,152,
Mm-hmm.
98,152 times parentheses 0.9858 raised to the 10 power. Yeah, so it goes down to about 85,000.
Mm-hmm.
And so to hit 80,000 will take even, a little more time. So yeah, that's all. All
Mm-hmm.
right. So now let's move on to page 2. Okay, so here you kind of want to find a common base. Like if I have 1/6, I kind of suspect that should change the 6 to -1 power.
Yeah.
And that's gonna be 6 cubed.
Mm-hmm.
And that's 6 to -3 power.
Yeah.
So 6 to -3x minus 2.
Mm-hmm.
That's 6 to 9x. So you add the exponents.
Mm-hmm.
The bases are the same, so then the exponents have to be the same. So I modeled for you. Now I'll walk you through the next one, so
Mm-hmm.
so you can practice it.
Mm-hmm.
X is -1/6. Okay. So we do something similar for number 10.
Mm-hmm.
So 1/4 is 4 to what power?
4 to the point 2 power.
Just like
No,
we did for 1/6,
4 to it's 4 to the point 5 4 to the
you're flipping it. What do you do when you flip?
you divide. Wait, no.
No, no. Remember, 6 to -1. Anything raised to -1 is,
Oh, it's -1
yeah,
then.
it's -1. That's all. And 64 is, of course, 4 cubed, right?
Mm-hmm.
So remember, use your properties of exponents. So what happens when I have -1 raised to 2x plus? Well, how do I combine these exponents? That becomes what?
Wait, which one? You can. It's um.
Remember, we talked about this. So you have 2 squared raised to the third power. That became what? 2 to the
Sixth.
right. So you multiply. So it's going to
Yeah.
be like
So one.
-1 times 2x plus 1.
Wait. -1 times 2x plus 1. -1.
Mhm.
-2 plus 1. It's -1.
No, you're just multiplying, dude. -1 times 2x plus 1.
-1 times 2 is -2.
-2x.
Negative
Keep going.
2x. Plus 1 is -3.
Dude, you're just multiplying. Negative 1 times 2x, negative 1 times 1.
1 times 2x.
So negative 1, you're just distributing. That's all.
Mm-hmm.
So what do you get when you distribute it?
Negative 1 times 2x is negative 2x.
Negative 2x,
Negative 2x.
right?
And
What's negative 1
then
times 1?
it's negative 1.
Okay. Do
Yeah.
the same thing on the next side. 4 raised to what power?
4 is the third power, so it's 3 times x, and then it'll be 3x.
So
Yeah.
3x,
And
and
then negative 3x.
you're multiplying 3 to x minus 1. You're just distributing it.
Hmm.
So what's that going to be? 3x.
And negative 3.
Good. Okay. Now, what do you notice is the same on each side? The bases, right?
Yeah.
So the exponents are also the same. So now solve, let's set the exponents equal to each other
Hmm.
and solve for x.
Yeah.
Okay, now solve for x. So much to go when you solve for x.
So for x, 4x.
You're solving for x. What does x equal?
So let me run out of step. I did plus 1 to get the negative 2x isolated.
Okay, you could do that.
And then I do the same thing on the other side. Yep. Whatever you do one side, go to the other side. I do plus 1 plus negative 3.
So you subtract 3x from both sides,
Yeah.
right? Because you want to get rid of that 3x. So so
Yeah.
keep going.
And then you get negative 2x equals 3x minus 2.
Right, keep going.
And then you want a plus 2 and then plus 2 on the other side to get
No,
rid of
just leave
that.
it where it is. It's just well, hold on. I thought you were moving the 3x over from right to left.
Oh, yeah. So it'll be negative 3x.
Okay, so what does left side become?
Negative 5x.
Okay, good. Equals negative 2.
Hmm.
So what does x equal?
X equals negative 3. Negative 3.
No. You have negative 5x equals negative 2. What's your next step?
Minus it.
Okay,
Right?
how's negative 5 being connected to x?
Oh, divide it.
Right. You know this.
Yeah.
Okay, so what's your final answer?
Um, X equals easy
Just
calculator.
what's just you have negative 2 or negative 5, so you just say
Oh, it's from oh, I know the percent. It's
just some of
40%.
the fraction.
So
You divide two negatives, so it becomes positive, right?
positive, yeah.
So you're just gonna say 2/5.
Yeah.
Okay, dude, you really got to figure this out, man. You cannot be making. I mean, this is like going back to 4 years ago. So really, let's keep going because I'm concerned. Let's keep going. All right. Next up,
Mm-hmm.
okay, number 11. Okay, so remember
This one's not going to be on the test. This type of problem's not going to be on the test.
11
That's
and
why
12.
it's X'd out, yeah. Because he
So how
made
how
an
how come, how come that was not X out? It's the same thing.
no, it's because he made an error while writing the problem.
Works out fine though.
No, well, he said like there's some issue with it. And he says like just not to do it for homework for some reason. I have
Okay.
no clue why.
I mean, it's the same thing on the next page. That's fine. All right, I'll skip it. It doesn't matter.
Yeah, I don't know
Let's
what.
come back to 13 and 14. Let's just because we're already talking about this stuff. Let's look at here. Okay. 1/8 and 32. So you're gonna use 2 as your common base.
Mm-hmm.
So that's 2 cubed. Because I know
Yeah,
if I multiply 2 3 times, I get that. How many times do I have to multiply 2 to get the 32? You can use your fingers if you need to.
16.
No, how many times do you multiply 2?
Hold on. 4 times.
No. because 2 times 2 times 2 times 2 is 16.
Times two times two times it's 4. Damn it, no. I should let me do this.
You're close.
5? No.
Yeah, yeah, it's fine. Yeah. Mhm. Okay, so that becomes 2 to the 5x plus 5.
Mm-hmm.
And remember, when it's on the bottom, you can make that a negative exponent.
Yeah.
Remember, we talked about this, you distribute it. So it's 2 to negative 3x plus 9.
Mm-hmm.
And why do we do this in the first place? To make these identical.
Mm-hmm.
So those are identical.
Yeah.
So negative 3x plus 9.
Yeah.
And you can move the 5 over from right to left, negative 3x from left to right.
Mm-hmm.
X equals 1/2. So we're going to do something very similar over here.
Mm-hmm.
Now remember, you want to change these to have the same base.
Mm-hmm.
So 1/4 equals 4 to negative 1.
Yeah.
64 equals 4 cubed.
Mm-hmm.
If I just multiply 4 a certain number of times to make it make sense.
Yeah.
All right. So now we use our properties of exponents.
Mm-hmm.
Let's look at the right side. That's really 4 raised to what power?
For the one on the left.
We'll see the right side. It's easier. 3 raised. So
So it's 3x minus 3.
too good. So you're seeing the patterns like that. And how about the left side?
To negative 2x plus negative
Minus
2
minus 2.
minus 2.
So then these have to equal each other.
Mm-hmm.
Okay, keep
Okay.
going.
Uh,
Keep going. What do you get?
for which one?
Number two?
Yeah.
2x minus 2 equals 3x minus 3.
Um, plus 3 plus 3. If you want to do it that way.
Okay, so you get 1 on this side. Then you
Negative
add
2 there.
2x, you get 5x. So x equals 1/5.
Mm-hmm.
Okay,
They start making a little bit of sense to me now.
so let's keep working through it. No, yeah, I mean, I know the concept is for it's just when the algebra, the linear stuff, like that stuff, you should not be
Yeah. I'm
messing
up to
with.
like, yeah, except.
So okay, so 1/27
Mm-hmm.
and 9. So we need to find a base that when you raise the base to a certain number, you get 9 and 3. Um not so what base can you use for 9?
Um,
Like you raise it to some power.
wait, sorry, I completely like my
Yeah,
internet.
yeah, yeah. So you have 1/27, you have 9, right? So for example, can you raise 2 to some power to get 9?
No, it's 3.
3,
Yeah.
right? So 3
Yeah.
to what power gets you 9?
3.
That's 3 times 3.
Oh, 3. It's 3 to the second power then actually it
Good.
is. So
And then for this is this is gonna be negative
yeah.
because it's on the bottom.
Mm-hmm.
So, but how many times do you have to multiply 3 to get 27?
3 times.
So it's negative 3.
Mm-hmm.
Okay, then continue combining it.
Okay, so that's negative 6x and then plus negative 6.
Okay, so we're just saying negative 6. And then here, combine it.
Mm-hmm.
What do you when you combine it?
Wait, what?
When you combine 2 with x minus 4?
Wait.
Just do the same thing we did on the other side.
Oh, yeah, I got this.
So what's
Um,
that going to be?
Oh, it's in 2x. It's
minus,
8.
okay, keep going.
And then you want to do plus 8, so that'll be positive
Good.
2 on the left,
And
and
then
then
add 6x, that becomes,
negative 4x.
nope, 8x.
Oh, 8x, yeah.
What was x equal?
X equals 1/4.
Good.
Mm-hmm.
Okay, let's look at 4. So we'll probably do 3 again.
Mm-hmm.
So I did -4 because you have to multiply 3 4 times and -3.
Mm-hmm.
So these combine and these combine.
Yeah. Mm-hmm.
And you keep moving things around.
Um,
So I'll let you work out how much you get.
all right. All right, I'll do this real quick. Just give me a second.
Yeah, it's just combine the x's, combine
I
the
got this
y's.
one. Just give me a single second, and then this will be complete. It's -1.
Nope.
Wait, what?
Add 6x to both sides, add 4 to both sides.
Oh, I completed that wrong. Oh my gosh. Yep. 6x, so it's positive 2. And then um plus 4 and then plus 4 and then that's 10. And that's it's 1/2, so 1/2.
No, 2x equals 10.
20%. So that'd be 1/5.
Nope.
Wait, 2x? But I thought 2x implies
2x equals
1/5.
10. 2x equals 10. 2
Oh,
times x equals 10.
x is 5.
Right. Right. Um, well, let's come back to inequality because I know we haven't done these yet, and I gotta sign off in a few minutes. Let's see here. So 1/2, you can write that
Mhm.
as 2 to -1.
Yeah.
So it's x minus 3. 8 grows 2 cubed.
Mm-hmm.
So it's -x plus 3 is greater than 6x.
Mm-hmm.
Move things around. Divided by 7, so x is less than 3/7.
Yeah.
Yeah. Okay.
Mm-hmm.
Or here, that's 3. We know it's -4 now. Actually, we could keep it as 9. 9 to -2. So therefore, -2 is less than 2x minus 4. Add 4 divided by 2. X is greater than 1.
Mm-hmm.
Um, I'll kind of just tee this up for you and then we'll enter call. So that's 3 to -1, x minus 4, 3 to the 4, 2x plus 1.
Mm-hmm.
That's negative 3.
Mm-hmm.
Actually, make it 4 squared.
Mm-hmm.
B to the fifth.
Mm-hmm.
And then you simply would just combine this,
Yeah.
combine this, combine this, combine this, combine this, combine this, combine this, and combine this. And then
Yeah.
solve. So, okay. Do you know when you have a test on this?
What?
And tomorrow's a quiz, right?
Yeah, it's not like the real test.
When's the real test?
I don't know exactly yet. We'll probably find out tomorrow.
Okay, well, I'll send my schedule to your mother. So,
All
okay.
right, sounds good.
Yeah, cool. I'll stop this then.
Mm-hmm.
All right. I'll see you later.
All right. All right. Have a good one.